And our guest today is Dr. Shane Siers with USDA NWRC, the National Wildlife Research Center in Hawaii Field Station. And he's going to be talking to us about his recent work on mongoose toxicant research. So, Dr. Siers, welcome.
Great, thank you. Thanks, Randy. Presentation's also in cooperation with Robert Sugihara, who's been deep in the mongoose stuff at NWRC for a long time and been in on our work from day one. So in addition to the toxicant stuff, I also added a few other aspects of what we've been doing with mongoose research recently. So with that, Randy, next slide. A lot of words here. You folks are all mostly pretty well aware of the situation of mongoose in Hawaii. Just included a little bit of background information, a history of introductions. Obviously mongoose were introduced as biocontrol by sugar planters for rat control. Currently on Hawaii, Maui, Oahu, and Molokai. There were introductions to Kauai, which were unsuccessful, and they were not introduced to Lanai. So currently they're distributed through Hawaii, Oahu, Maui, Molokai. They're in urban areas, around homes, farms, agricultural areas, and natural areas, including forests and wetlands. They do really well in degraded habitats, waste areas, and industrial areas, and they range all the way from sea level to 3,000 meters elevation. And the home range of mongoose has been estimated at about 10 to 90 hectares, with males ranging more broadly than females. They're generalist predators. They reproduce year-round in Hawaii. They've got an omnivorous diet. They feed on invertebrates, fruits, eggs, rodents. They're also pretty good scavengers. They capitalize on a lot of anthropogenic food sources, carrion, trash. They've got limited climbing abilities. They're able to cross streams and irrigation ditches, and in Hawaii they've got no natural predators. The impacts have been predation on upland and wetland ground nesting birds and eggs. They predate on sea turtle eggs and hatchlings. They also prey on native invertebrates, and including some of the threatened tree snails. In agricultural areas, they're a big problem of feeding on eggs, chickens, ducks. They're also known to carry diseases such as leptospirosis, and not in Hawaii, but a big problem in Puerto Rico is they're a major reservoir of rabies. And they can also be problematic from a sanitation standpoint. Mongoose problems around food processing facilities and in public areas like parks and beaches, where mongoose just shred trash bins and spread trash around. So with that, we'll get into the next slide, Randy. And this, I'm not going to read all this to you, but NWRC Hawaii Field Station and the Rabies Project have a long history of mongoose research, covering everything from home ranges to baits and lures and bait stations, difascinone as a toxicant, estimating density, working on vaccinations for rabies, mongoose's bioindicator of trace element pollution, ecology and management of mongooses, effects of mongoose odor on rat behavior, potential use of biomarkers for mongoose censuses, scavenging of mongoose carcasses, and including genetic work on the origins of mongoose found in Kauai. So where was the source population of those? So just we got a long history at NWRC with mongoose work. Next slide. So traditional control tools, most of what's being used currently for trapping mongoose are cage traps. They got high labor demands. They have to be checked daily. Then the mongoose have to be subsequently euthanized, either through shooting or CO2 euthanasia. So it adds another layer of labor and risk and complication. And the cage traps can also pull in non-targets. Upside of cage traps is those non-targets usually survive and are just released at the location. As far as toxicants for mongoose control, currently the only registered product for chemical control of mongooses is Ramic minibars. It's a difascinone product. I'll touch a little bit in a bit on there's pretty low acceptance. The consumption rate of the Ramic minibars by mongoose is pretty low, and there's been some speculation that a lot of the effect of Ramic minibar use on mongoose suppression actually comes through potentially secondary intoxication of the mongoose after preying on rats or mice that may have been eating the ramic bars. But currently it's the sole option for chemical control of mongoose, and as Patrick can attest to, recent lapses in registration of the product meant there was no alternative for chemical control. So we're interested in potentially coming up with some additional tools that may be better for targeting mongoose, and just add another tool to the toolbox so we don't have all of our eggs in one mongoose predated basket. Okay, so I'm going to start off with some work that occurred, was just wrapping up as I came aboard at the Hawaii Field Station as Fish and Wildlife Service funded evaluation of palatability and toxicity of candidate baits and toxicants for mongooses. So basically what we did is just did a screening of commercial rodenticides and some new artificial ingredient, or not artificial, sorry, got brown tree snakes on the mind, active ingredients for a mongoose bait that there currently are no registered products for. But basically those were sodium nitrite and PAP. PAP is para-aminopropionophenone, sorry for not having that memorized, but everybody calls it PAP. So we went through a whole list of rodenticide products, and then we tested sodium nitrite and PAP and technical diphacinone, so just not in a rodenticide, just the concentrated active ingredient, all in minced chicken. And the results of that were basically the Ramic mini bars, diphacinone, that's the one currently registered product, we only got 20% efficacy. The carnivore dentition was just not great at chewing off those chunks of that hard waxy block that's really meant for gnawing rodents. A surprise was the tomcat bromethalin, which is also a hard block. We got 95%. We actually got 100% in the first phase, and we were like, wow, that's kind of an unexpected result. So let's try it again in another batch. And I think we got 90% in that batch. So between the two, we got 95% effectiveness with bromethalin. I'll talk a little bit more about the differences in a bit. Technical diphacinone in minced chicken, so just the powder in some minced chicken, was very successful. Mongoose appear to be really susceptible to diphacinone. I forgot to mention earlier, there used to be a registration for hand-formulated diphacinone by just mixing the powder into hamburger and using that in the field. But that went by the wayside. It wasn't being used, and partially because just the added, you can't just take a bucket of this stuff and just fill a bait station. So actually having to mix the powder in with the hamburger, just nobody was doing it, so the registration went by the wayside. Sodium nitrite in chicken, we expected to do a lot better, and it really only got to 10 to 30% efficacy, but we think that's because the sodium nitrite is basically, it's a super salty preservative, and it has to be microencapsulated, and mixing it into that wet minced chicken we think broke down the microencapsulation and making it super salty, and you could just tell that the chicken got all crumbly and desiccated because of that sodium nitrite breaking down in it. So we still think there's some potential for sodium nitrite. We just got to get some encapsulation issues figured out. Basically the bottom line was that consumption of hard rodent products was low across the board, with the exception of bromethalin, and I'm going to look a little bit more into those tomcat blocks and see what was so great about that. But so that was that study. We can kick over to the next one. We got some HISC funding to advance the development of a new mongoose toxicant, and our first step in that was sort of to go to our registration unit and do a well-informed, thorough digging down into what's it actually going to take to get a new product across the finish line with respect to how much it's going to cost to do all the tests necessary to register a product with the EPA, and how long it's going to take to get through the EPA registration process. So the four toxicants we looked at were diphacinone, which is an anticoagulant, bromethalin, which is a neurotoxin, and PAP and sodium nitrite. Both of those cause methemoglobinemia, and basically what that is it causes the red blood cells to not be able to uptake oxygen, so basically they suffocate on CO2, which is sort of akin to euthanasia by CO2, which is an accepted practice with the AVMA. So they work pretty fast. They're pretty, it's a humane way to go, and if the animal survives, there's almost no lingering effects, and there's very little potential of secondary contamination. So if a mongoose dies from methemoglobinemia, EO eats the mongoose, it's unlikely to cause any problems for the EO, which we can't say about the anticoagulants. But again, we went into evaluated the registration and commercial lab testing costs and EPA decision times, and also for various use patterns. So we looked at the cost for just starting with the lowest hanging fruit of use in bait stations only, and then what it would take to get that expanded to hand broadcast in areas. So bottom line is the cost lowest to highest. The easiest barriers to registration is going to be diphacinone. It's already a mongoose registered product. Bromethylene is registered in Hawaii for various rodent uses, and sodium nitrite is going to be a lot more expensive and a lot longer to go, but our hopes for getting there somewhat more easily are kind of tied up with trying to get sodium nitrite registered in the U.S. for feral swine control. That's the big market for it, and if they can get that across the finish line, adding mongoose to that can make it a little bit easier for us.
And then you don't even have to treat the pork meat that's already been treated.
Right, it'll last forever. Yep. Spam without a can, yeah. And PAP is going to be the hardest. PAP's not registered in the United States for anything. It's not looking like it's going there anytime soon. If we're going to ride on somebody's coattails, my fingers are crossed that it's going to come across as a means for feral cat control. It's being evaluated for that in Australia and New Zealand. But again, that's way further down the line, and getting it registered is going to be by far the most expensive.
Is anyone working on it?
Not in the U.S. As far as I know. Along with that registration potential review, we looked at the humaneness of the potential toxicants. Humaneness is not an EPA requirement, but it does help us to get social license, get the stakeholder buy-in to actually be able to use the products. So we reviewed the mode of action of the product, neurotoxin, anticoagulant, methemoglobinemia, the level of awareness of the animal as it's succumbing to intoxication, signs of distress that animals exhibit while succumbing to intoxication, the severity of the signs of distress, the duration of those signs of distress, and then the eventual time until death of the animal. And in our final analysis, basically it comes out the least humane is the diphacinone anticoagulant. Takes a long time. Animals kind of hunker down and feel sick for that long period of time. There's bleeding. Sodium nitrite and PAP, when it works right, it's works pretty quickly. It's pretty much lights out, and they really, like I said earlier, it's akin to CO2 euthanasia, which is an AVMA approved means of euthanasia. Some other things to think about in selecting a toxicant: antidotes, anticoagulants. If there's accidental exposure to an anticoagulant, vitamin K therapy can be used as an antidote if it's in pets or children. Sodium nitrite and PAP and bromethylene, which is a neurotoxin, we don't have antidotes to those. And then there's also convenience of use is going to be something that'll be weighed in the long run. So we've got, with having all that behind us, and that's all out in a Management of Biological Invasions paper, which I've shared with most of the people in this room, and if anybody hasn't seen it, feel free to ask. We can direct you to it, but that was the first solid product that came out of that HISC funding. The next is moving on to figuring out an improved bait matrix. So when we figure out what the right toxicant is, we want to figure out how to get it into the mongoose in the best way. We need a bait matrix for that. That toxicant's going to need to be mixed into something that the mongoose is going to consume. So as we said earlier, ramic minibars and other commercial rodenticides are kind of too hard for the mongoose carnivorous dentition. We want something they can really sink their teeth into, literally. We recently did some partially HISC-funded cage trials to assess the acceptance of some alternatives. Our 5 candidates were Foxacute and Fox Shield, which are 2 Australian products by ACTA, Australian Control Technologies. They're intended for fox, as you might have guessed. They're in their current formulation, it's a PAP. PAP is the toxicant in them, but they're meat flavor or fish flavor, and they're a little chewier. They're a little easier, a little more developed for a carnivore's dentition. Hog-On is this sort of peanut slurry paste that's being developed for feral hog control. Also an active product, and it's in its native formulation, it's a vehicle for sodium nitrite. So this is an artificial brown tree snake bait that our group has been working on. Bruce Kimball's with our chemical senses unit in Monell, and it's a homemade spam that's got a what Bruce did is he took a bunch of dead rotting mice and turned them into a slurry and fed them through a GCMS and got the spectral peaks of what smells like a dead mouse, and then found some artificial ingredients that match those peaks, mixed them together in this lipid mixture, and mixes it into what I'm calling pork loaf with artificial mouse scent. So we can make this ourselves. We can turn it over to our Pocatello Supply Depot, which is basically the pesticide distribution unit for wildlife services, and they have facilities where they can actually produce stuff. So we're considering it as something that can be somewhat in our control. A big thing to think about in all these things is the invasive mongoose problem is kind of a niche market, and to get a big pesticide manufacturer to retool to use a new active ingredient in their current matrix, or to come up with a new matrix to use their current active ingredient, it's a little bit out of our control, so we wanted to consider that. The other one is this talpirid, which is basically it's like a gummy worm for moles that Bell Labs makes. It's got bromethalin in it. We weren't able to get a placebo version of the talpirid, so we didn't include this in the cage trials. But basically we wanted a placebo version, non-lethal trials, just to see what the mongoose would gobble up. So we can go to the next slide.
With the BTS bait, what toxicant are you using there?
Acetaminophen.
For mongoose?
No. So that we could basically incorporate just about anything that's
right.
It's got a high moisture content, so microencapsulated sodium nitrite might not be
Right.
a workable solution, but we can mix in whatever we want,
Okay.
whatever we can
You
get
haven't
registered.
actually formulated it yet.
No.
mongoose.
Yeah, we just go with the placebo. We didn't want to mess with that until we found out whether the mongoose would like it or not. It was kind of a slam dunk, mongoose gonna like spam, sure, of course. But we just wanted to demonstrate that and see how well these worked out. So we did some cage palatability trials. We had 6 mongooses per trial, 1 trial per candidate matrix. It was a 2-choice test. They were offered the new bait matrix and a dried dog kibble as a challenge diet, just so they had something else to eat. It wasn't that they were starving to death and that's why they were eating it. I really don't like the kibble though. I'll get to that though. But we offered 70 grams per feeding, 5 days of feeding, and each feeding window we limited to only 4 hours per day. And the reason for that is any bait that has sodium nitrite or PAP, they start to clear that so quickly that if they just nibble a little bite here, come back for another bite a couple hours, another bite a couple hours, they'll have processed it through and never have accumulated the necessary critical dose at any one time to cause the methemoglobinemia. And we figured that a limited exposure window would also more realistically mimic what A mongoose foraging in the field comes across a bait station. It's not going to take a bite now, come back in a couple hours, take a bite. It's going to scarf down all it can get at that time because it's probably pretty hungry. So that's why we limited to a four-hour exposure window. And the result, basically, can you play that video, Randy?
Let's see.
So this is just a little time lapse. We recorded all this with video so we could tell whether the mongoose were just sampling it throughout the time or whether they were gobbling down whole chunks of it. So the first was fox acute. This is the fox shield. Sodium nitrite paste. Again, these are placebo, so there's no toxic ingredients in here. And the brown tree snake bait. And the end result, daily consumption, they really didn't like the kibble challenge diet. On average, they'd only eat 2 or 3 grams of that a day. The hog-on paste was our lowest performer in pure consumption, 13 to 15 grams average per day. Fox acute got a little better at 14 to 20. Fox shield did really good at 20 to 23, and pork loaf was the most highly consumed product at 25 to 30 grams per day. Basically, though, bottom line, all of these are likely adequate for getting a lethal dose to mongoose. So, on one hand, we were hoping to have a clear answer of what we're going to go with. On the other hand, we got 4 really good options. So that's more options is better. What we actually,
I was going to ask, is the pork loaf more perishable per se?
Yeah. So the other characteristics that are gonna lead into what we actually go with are going to be things like compatibility with the toxicant. Like we said, anything with a high moisture content is probably not going to be compatible with the microencapsulated sodium nitrite. So if that's the way we were going to go, we probably wouldn't want a real wet bait. Field and storage longevity. So the brown tree snake bait comes in these. It's actually sort of it's heat pasteurized inside a foil envelope, so it can store at room temperature for a long time. We don't yet know how long it will actually remain palatable to a mongoose once it's sitting out in the field for a few weeks. So we'll get to some of that in some of the next steps. Availability and manufacture. Again, if we can't get anybody to produce it for us, that's gonna count against it. And then convenience of use. Like the fox acute blocks, they come in those nice little blocks with a little pinhole in them for bait station use. That's really convenient. The brown tree snake bait, currently the way it's made, you have to cut up a little loaf and slide it onto the pin in the bait station. The hog-on paste, probably not going to be really good for convenience of use because it is a paste. It's going to gunk up those bait stations, make it pretty hard to keep it really neat and clean. Also found out things like I also recommend in our report that anything that when they are used in bait stations, we should probably use the vertical pinning system as opposed to this horizontal pin, because you can see the weight when they start to chew at the top, the weight is all below, and the mongoose continue to chew at the top, and it just fell off the pin. So now there's a big loose chunk that something could actually grab and just drag out. But if we just put it on the vertical pins, then that's less likely to happen, that they'll get big chunks of this off. So next slide. So our next steps, where we're going with this, is we want to try cage trials with the actual toxic formulations. We're probably never going to get PAP registered in the U.S., at least in a near term, but there is a product that is being used elsewhere that they do like to eat. We would like to know whether PAP, as formulated with the manufacturer, the mongoose would take it. So basically, we want to repeat this with the active ingredient formulations of these products, and that's where we can bring in the bromethylene gummy worms with the telpyrid as well, because we can get that just off the shelf. Also, it turns out basically the talpirid just off the shelf probably will be an easier registration, even though bromethylene is more difficult than diphacinone. The diphacinone will probably end up having to be in a new end-use product formulation. So it's a new combination of the active ingredient and the bait matrix. So that's going to have to go through a whole battery of tests to get EPA approval. Whereas if it's just adding Mongoose alongside moles on the registration of a currently registered product, that's easier. I'm not sure how easy it's going to be to pin the gummy worms to a bait station without them being pulled out. But anyhow, yeah, so the next steps are the cage trials. Then we're going to have to come up with, what's our final bait matrix and active ingredient selection? What are we going to really move forward with getting registered? We'll probably have to do some dosage range finding. How much of the active ingredient is actually necessary in the product? We want to keep it so low that we're not putting out too much toxicant, but high enough that we're not risking underdosing the mongoose. Then we're going to do some field longevity trials. How long does the bait remain palatable in a bait station? That'll be really important in places like Kauai, where, at least if the rats aren't eating it, if nothing's eating it, you really want it to last a long time because it's more of a biosecurity and surveillance thing. We'll do field bait uptake trials, both with mongoose and non-targets. So product isn't going to be really good for mongoose if rats just come in and gobble it up and there's nothing left for the mongoose to get to. So we're going to put some cameras on some baits and see what actually happens. And we'll also have some treatments where the entrances to the bait stations are screened off. We can evaluate just what the invertebrate impact is on the baits without dealing with the rats and mongooses. We've got some a little bit of HISC funding coming up in FY20 for a mongoose-specific bait station. Kind of get at that problem of trying to get it so where mongoose can get it, but rats and mice can't. And once we come up with what we actually want to get across the finish line, we'll do some final cage efficacy trials to what they call good laboratory practices standards. It's a added layer of documentation and scrutiny and inspection on the lab trial that makes it EPA quality data, and that's we've got some HISC funding for that. And then we'll want to do an actual active ingredient field efficacy trial to support the EPA data submission. We'll have to go through the experimental use. We'll have to get an experimental use permit in order to do that. So that's kind of a big deal to get done. And then there will be a battery of EPA required lab studies. Probably be done by commercial labs where they just there's things like storage stability and effects to various toxic effects. There's what they call a six-pack. I don't know what's in the six-pack, but it's basically a suite of studies that every new pesticide has to go through, and those are typically farmed out to a commercial lab that just they just crank through those things. That adds expense.
Would a commercial lab have access to mongoose?
Well, a lot of it is not mongoose specific. It's like toxicity to birds, toxicity to what happens if it's in water.
Okay.
What is it? So
yeah. It's the standard bobwhite quail.
Probably, yeah. Yeah. So that's a lot of stuff here still to get through before we can get a product across the finish line with EPA.
Hey, Shane?
Yeah.
This is Josh Fisher. Just a real quick question. To get to the finish line, the lab trials and the EUP field trials, do you just kind of have an approximate cost estimate, or do you already have funds lined up for that kind of stuff?
We have a small amount of funding lined up for it, but not nearly what it's actually going to take. I'm trying to think of how much. So the stuff that we would do probably won't vary a whole lot depending on what the matrix is and what the toxicant is. We haven't put a whole lot of energy into like nailing down the price tag on everything just yet because we're not getting there. But we should probably do that because it sounds like Fish and Wildlife is interested and might potentially have some funding to help augment that. So we can come up with some more hard budget estimates to get us at least our part of it across that finish line. And then Emily Rule in our registration unit, she can come up with the costs of what the EPA 6-pack would cost and things like that.
Okay. Yeah, I just want to ensure that I submit things early and then just continually socialize it because it's getting this across is important.
Yeah, great. I think I had in my mind that around the November time frame is when you guys suggested we should start talking about funding for the next year. Is that
Sounds
right?
about right.
Yeah. Okay. Yeah, we were planning to chat with you about that around then. Okay, so any questions about the toxicant piece before I move on to just some of the other stuff we're doing?
Just wondering if you had any idea about a time frame for getting through the last of those things on the next step slide.
I could put out what I think is right now might be the time frame, but unfortunately, history is teaching me that my prognostications on how long things are going to take are overly optimistic. But we should. I'll try to map that out, and I'll share that with you and Fish and Wildlife Service. Yeah.
With the methemoglobin path and nitrite, you said if animals go off of it, they survive. Is that because the methemoglobin is reversible, or is it new synthesis of red cells?
I think it's just because I think the circulating levels of the toxicant is what temporarily causes the lack of ability to uptake, bind the oxygen cells. So the metabolism of the circulating levels of the toxicant, they metabolize it so quickly, and then once it's out, it's no longer circulating, it's no longer blocking the uptake of the oxygen cells.
So it's reversible in the hemoglobin.
When I think reversible, I'd say it's naturally self-reversing. When I think reversible, I think we can intervene in a way that can save that animal and stop the process of the methemoglobinemia. I don't think there's an interventional reversibility as far as I know, but it will reverse it. The process, it will reverse itself given enough time if the animal doesn't die.
It doesn't require the synthesis of new hemoglobin. The liver doesn't remove the methemoglobin and require the synthesis of new hemoglobin.
Yeah, I'm personally not sure of that, but from what I know of, basically, it's within a matter of hours. If they don't succumb, they clear it. So
that's not synthesis of new hemoglobin.
yeah, I wouldn't think so. Yeah. Yeah. Okay.
Great.
All right. Well, just touching briefly on other mongoose stuff that we've been working on. So, Goodnature, is everybody familiar with the A24? They're working on a modification of the A24. I didn't know this until we got into this. A24 means automatic 24 firings. So it can kill 24 rats within a single charge of a CO2 cartridge. So the A18, it's got a bigger bolt, it's got a bigger punch for bigger animals, but you can only get 18 punches out of a CO2 cartridge. So they're calling it the A18. It's considered an automatic trap. It's a CO2 fired self-resetting captive bolt. So you see the nice little schematic they give here. They check out the bait. They hit this trigger here, which releases the bolt, crushes the skull. Blunt force trauma is also an AVMA approved means of euthanasia, so this is considered really relatively humane. Then it resets itself and is ready for the next animal to engage with it, and then the carcasses are typically scavenged, whether it's by a predator or insects. So 18 firings per cartridge. It's currently being sold as a squirrel and mink trap in the European Union. It's in testing for its effectiveness for mongoose, and Michael could probably tell you more about the successful field trials that Fish and Wildlife and representatives from Goodnature did some field trials on Oahu, and basically, demonstrated that you can pretty much really knock the numbers of mongoose down pretty quickly using it.
Tyler will be there tomorrow, and he's the expert on that.
Okay, great, great. And so the next slide. So Fish and Wildlife funded our lab to help Goodnature with their humaneness evaluation. So New Zealand has a humaneness standard. As I mentioned earlier, there's no U.S. standard for humaneness yet for a field tool. So they asked us to evaluate the humaneness of the A18 on mongooses. So the humaneness standard, basically, they've got this little table of how you can go through it. If you get 10 animals with so the main test of whether the animal's been humanely dispatched or not is how quickly the palpebral reflex goes away, and that's just when you touch near the eye. If it blinks, it's still got a palpable reflex, and loss of that reflex is sort of a recognized standard of, loss of awareness, loss of higher critical function, meaning the animal's probably not suffering anything during that time. So if 10 animals get through with none of them having the palpable reflex persist for longer than 30 seconds, you can consider it done. Or 15, 2 can get past 30 seconds, but none can get past 3 minutes. Or out of a sample of 20 animals, 3 can go past 30 seconds, but no more than 1 can go past 3 minutes. And that's the New Zealand standard, and that's what they were looking for with our cage trials. So what we did is we conditioned the mongoose to having a feeding arena where for like a week up until their trial, we were just placing food treats in odd little hard to get to places. So we were conditioning them to looking for their food by exploring scents, and as you figure, that's how a mongoose is foraging in the field. It doesn't have something handed to it. It's going around looking for stuff. So we conditioned them to it in this feeding arena, and then we put in the A18 at the same height that it would be feeding from, and so that was what our arena looked like. And then we had continuous auditory observation. So basically, our technicians were hiding behind a screen where the mongoose couldn't see them, but they could hear when that punch would go off. And then we also had video monitoring as well. But as soon as they heard that punch go off, the technicians would rush in, and if it was safe to do so, would get their hands on the mongoose and start doing that palpable reflex thing, and record the amount of time it took for the palpable reflex to desist. And if the palpable, that's a typo I tried to fix this morning, but I had a problem with my computer version versus the thumb drive version. So that should be 3 minutes and not 30 minutes. So if the palpebral reflex went beyond 3 minutes, then we would take the animal and euthanize it with isoflurane inhalation. So next slide. These were our results. We got down all less than 30 seconds up until animal number 7. Palpable reflex persisted beyond 3 minutes, so it didn't meet that criteria for humaneness. So we had to go to the next criteria that allowed any animals to persist beyond 3 minutes, and that was the 20 animals. And we got all the way down to animal number 19. We got another one that didn't meet that. So the trial stopped at 19, and we came up short of achieving the New Zealand humaneness standard for the A18. So next slide.
I'm confused because it says 2 minutes and 30 seconds.
Yeah, so if you want to go back. there's that little note on there. Basically, palpable reflex was not able to be checked beyond 2 minutes and 30
because it
seconds
was,
due
like,
to animal
alive.
movement and the safety
I
of the
see.
observer. So that mongoose was still so alert and aware
I
that it
see.
wasn't safe to grab it. So it was clear that it didn't meet that. Great. Okay, so the next one. So that trial didn't achieve the humaneness standard. Goodnature was, not, everybody would have preferred that we got,
Sure.
a good result. So that made them, call into question a little bit. Well, was the artificiality of the arena, could that have led to the not getting what we wanted to get? So they came out with some A18s. Craig Bond and Robbie Van Dam of Goodnature came out to the Big Island, and they went out to a super mongoosey site. Turns out that somebody turned them onto a site in Kona, and it was just crazy crawling with mongoose. So they were able to actually put these out, just run back a little bit and hide and wait for a mongoose to engage and run up. And they were still kind of tweaking things in the field, like how much pressure was behind the bolt, observing, adjusting height. So they were sort of modulating some characteristics of what they were seeing in the field. But basically, they determined that their field experimentation was inconclusive, and the verbatim response just yesterday or day before from Craig Bond was, based on this testing, it is our belief that to achieve an acceptable humane standard, we would need to undertake modifications to the trap and conduct more testing. At this stage, we are not sure when this will happen. So that's where we are right now with the development of the A18. I feel a little bit vindicated that they didn't get a better result in the field than we got in the lab. So I think we were our study was I still think really pretty suitable. But it's all about the orientation of the head in that cone in relation to the trigger and the piston. I think the few times that it didn't in our lab that it didn't get the perfect hit, it was because there was lateral hits. It would come in from the jaw side, and probably got some pretty beefy muscles there, probably absorbing some of that impact as opposed to a real good square cranial hit. So I don't know, maybe some sort of quasi excluder device that might force them to orient properly might get there. But yeah, we were really hoping that they would get the good result in the field, and these would be on the shelf any minute. But it's not really looking that way from the humaneness standpoint.
But when you say on the shelf, why does this block anything from getting on the shelf?
Well, they don't want to market it as a humane means of controlling mongoose until they've achieved that standard, and they really put their name on, hook their name up to the humaneness side of things. So they won't release it for that use until they know it's humane.
Even outside of New Zealand. Because it's
Right.
only New Zealand that has the
Yeah,
standard.
it's New Zealand standard, but they've kind of adopted that as their, central to their mission statement, that they can say that it meets the humaneness standard, and they won't sell it without that.
Interesting.
Yeah. That doesn't mean, actually this is a good time to get on to that, because that does come up to this last slide that I have. Is in the last round of HISC funding, the NWRC Hawaii Field Station asked for funding to compare cost effectiveness of A18 versus cage traps, which is what most people are using. At the same time, DOFA here on Oahu, Aaron Works and Lindsay Neatman had put in for funding to evaluate the relative effectiveness of A18s versus DOC 250s. And these are these big, massive snap traps that are also supposed to be pretty darn humane, because there's just no walking away from that. And it was the recommendation of the funding committee that since our studies were so similar, that we split the available funding for A18 evaluation. And we recently had a call with, Aaron couldn't make it because he had to go respond to a wildfire, I guess. But we talked to Lindsay, and because they were further along with their protocol, and because I'm leaving the Hawaii Field Station in October, and we don't have a replacement for me yet, and we don't have extra PI capability just floating around right now, we agreed with DOFA that we would consider them the lead, and we would follow their protocol, and we would do some study sites to add to their data set. We would do some on the Big Island to augment their Oahu data set and work cooperatively on this. So that's how we got that across the line, or are planning to get it across the line. And just with that, I'd like to thank NWRC's what they call Team Mongoose. Bob, again, he's got decades of mongoose experience. Israel's our biologist, been with us about 3 years, been through all these cage trials. Dean is relatively new with us. Emily Rules, our registration unit specialist in Fort Collins, Colorado, who was the first author on that registration review. Chris Niebuhr was our postdoc. He has since left us and is now with Landcare New Zealand, and he's also interested in continuing to be involved in this stuff as well, so his name will continue to be associated with it. And Ari Berenson, who, if you're going to the Mongoose Forum tomorrow, you'll meet Ari there. He's with our rabies project in Fort Collins. He's been tackling the mongoose stuff from the rabies standpoint of things, mostly working in the Caribbean, but he's done some vaccination evaluation and biomarker evaluation at our field station in Hilo. So that's our team, and with that, I'd like to thank our partners in Mongoose Control, Fish and Wildlife Service, Department of Land and Natural Resources, and Hawaii Invasive Species Council. So with that, I'll take any questions.
Great.